Dear students, Assalamu alaikum. Hope all of you are doing well. This is Irene Parveen. Welcome to Chemistry First Paper online class English version arranged by KPB School and College. Our today's topics are number 1 melting point and boiling point, and number 2 atomic and ionic radius under chapter 3. The title of the chapter 3 is Periodic Properties of Elements and Chemical Bonds. And you have already known that this chapter is very important for you. Now, I am like to discuss periodic properties of element. Before discussing today's topics, we have to know about periodic properties. The electron distribution of element changes with their increase of atomic number. The properties of the elements depend on their electron distribution with gradual periodic repetitions. So, periodic properties of elements mean the repetition of similar properties among the elements after a definite intervals according to their increasing atomic number. And the notable periodic properties of elements are melting point and boiling point, atomic and ionic radius, ionization energy, electron affinity, electronegativity, valency, metallic properties of the elements. Now, I am going to discuss about melting point and boiling point. The temperature at which solid substance melts is called melting point of the compound or substance. But the temperature at which liquid at 1 atmospheric pressure boils with bubble is called boiling point of that liquid. Now, I would like to discuss how melting point and boiling point change in group. For example, we see the boiling point and melting point of group 1 metals. Look at the table please. The melting point of lithium is 180 degrees centigrade and sodium is 97 degrees centigrade. The melting point of potassium is 63 degrees centigrade and radium and rubidium is 39 degrees centigrade and cesium is 28 degree centigrade. On the other hand, the boiling point of lithium is 1342 degrees centigrade and sodium is 883 degrees centigrade and potassium is 795 59 degrees centigrade and rubidium is 688 degrees centigrade and lastly cesium is 671 degree centigrade. From the above examples, we will see that melting point and boiling points of the group 1 elements is decreased if we go down from top to bottom. Now, I am explaining why melting and boiling point is decreased when we go from top to bottom. the atomic size of every element increases with the increase of atomic number, and electron density in valence shell decreases. As a result, metallic bond attraction decreases. Hence, the melting point of alkali metal decreases gradually with increase of their atomic number. But the atomic size of lithium atom is comparatively smaller, and its metallic bond is comparatively strong than others. For this reason, melting point and boiling point of lithium are higher than those of other alkali metals. So, we can say that the atomic size of the atom of a group whose atomic size is comparatively smaller, and then its metallic bond is comparatively strong than others. That's why the melting point and boiling point of lithium is more than that of other metals of group 1. Now, I would like to discuss uh, melting point and boiling point of the elements of third period. For example, here the melting point third period the melting point of the elements of third period, here the melting point of sodium is 97.8, and the melting point of magnesium is 649, and aluminum is 660, and melting point of silicon is 1410, and phosphorus is 44, only 44. Now melting point of sulfur is 112.8, and chlorine is minus 101, and argon is minus 189.2, and the boiling point of sodium is 883 degrees centigrade, and boiling point of magnesium is 1090 degrees centigrade, and aluminum is 2519 degrees centigrade, and silicon is 2355 degree centigrade, and phosphorus is 280 only, and sulfur is 444.67 degrees centigrade, and chlorine is boiling point of chlorine is minus 34.6 degrees centigrade, and argon is minus 185.7 degree centigrade. Now from the above table we can see that in a period there is no regular variation in melting point and boiling point. As element, some are metals, some are non-metal. In the period 3, that is sodium to argon, sodium, magnesium and aluminum have metallic structure. Sodium, magnesium and aluminum. Sodium, magnesium and aluminum have metallic structure. Their melting point and boiling point increase from sodium to aluminum. This happens because metallic bonds become stronger due to decreasing atomic radius. You have already known that if we move from left to right in a period, then atomic radius decrease and increasing nuclear charge. And another reason is increasing number of delocalized electrons. That's why the sodium, metal, magnesium, and aluminum, these metals have high melting and boiling point. And for silicon, in silicon crystal, giant molecule is present. For silicon, melting point and boiling point is also high because in silicon crystal, giant molecule is present in which silicon-silicon bonds form three-dimensional network. Here, mass heat energy is required to break those silicon-silicon bonds during the melting of silicon crystals. Hence, melting point and boiling point of silicon are very much higher. Now, look at the next element. Our next element is phosphorus. And melting point and boiling point of phosphorus, both of them are low. And what is the reason? In phosphorus, which exists as white phosphorus, P4 molecule, this molecule is covalent in nature. Van der Waals force exists as intermolecular force among these covalent molecules. You know that van der Waals forces exist in covalent molecules, so phosphorus has low melting and boiling points because van der Waals force is very weak force. And our next element is sulfur, and which exist as octaatomic molecule. Sulfur exists as octaatomic molecule, that means S8. S8 octaatomic molecules. The non-metal sulfur, and this is non-metal also, the non-metal sulfur atoms form covalent bonds among themselves. Here also weak van der Waals force exists among the sulfur molecules. Hence, melting point and boiling point of sulfur are lower. Now, look at chlorine. This melting point and boiling point of chlorine is very low uh, because chlorine molecule is diatomic. These diatomic molecules are purely covalent and nonpolar. So chlorine molecules remain attracted by weak van der Waals force. For these chlorine molecules remains as gas and its melting point and boiling point are lower than 0 degree centigrade, having negative value like minus 101 degree centigrade and minus 34.6 degree centigrade. Now I am going to discuss about uh, atomic and ionic radius. Generally, atomic radius of an atom is defined as the distance measured from the center of the nucleus to the point up to which its outermost electrons extend. Practically, determination of atomic radius is very difficult because the distance of outermost electron cloud from the atomic nucleus is uncertain. Look at the table place. Uh, Here, For example, we look the elements in second period, and the radius of the elements of second period are the radius of uh, atomic radius of lithium is 0.123. Look here, atomic radius of lithium is 0.123 and atomic radius of beryllium is 0.089, and next atomic radius of boron is 0.08 and carbon is 0.077 and nitrogen is 0.074 and atomic radius of oxygen is 0.073 and lastly fluorine is 0.072. So from the above data we can see that the atomic radii decrease from left to right in a period. I repeat it again, the atomic radius is decreased from left to right in a period. And now I will give the explanation of that. As the atomic number increases, the nuclear positive charge also increases. As a result, the nuclear attraction on the outermost electrons becomes intensified. Due to the gradual attraction force increment, the level of the outermost electrons become nearer to the nucleus. For this, the atomic radius gradually decrease, decrease when we move from left to right in a period. Now, our next table contain the elements of group 1A, and here we look the atomic radius of group 1A elements. Look here, the atomic radius of lithium is 0.123 and sodium is 0.157 and potassium is 0.203 and rubidium is 0.216 and lastly the atomic radius of cesium is 0.235. So, from the above data, we can easily understand that if we go down top to bottom in a group, then atomic radius increases. And now I am going to explain the reason of this. As we go down a group, the valence electrons enter into a new shell. That means as we go down a group, the a new shell is added. As the shell number increases, the atomic radius also increases. As a result, the valence electrons do not feel the full attraction of nuclear charge And here shielding factor of electrons is responsible for large atomic radii. Now look at the another table. Here uh, we see the ionic radii of group 1A and group 7A elements. Look here, the ionic radii, that means sodium ion. The radius of sodium ion is 0.097, 0.097, and the radius of potassium ion is 0.133, and the radius of rubidium ion is 0.147, and lastly the radius of cesium ion is 0.167. Now we will see the another group, group 7A. Here fluoride ion, the radius of fluoride ion is 0.133, and chloride ion is 0.181, and bromide ion is 0.196, and lastly iodine ion is 0.22. And from the above data we can easily understand that the ionic radii increase with increase of atomic number. We can say it in another way. When we go down a group, then the atomic ionic radii increase. And now I am explain what is the reason. Actually, ionic radii are also a periodic property like atomic radii. When an atom loses one electron, it becomes positive ion, and when one electron is accepted in the outermost shell, it becomes negative ion. Here, group 1 elements, here group 1 element loses one electron, and they become positive ions, and on the other hand here group 7A elements accept one electron and they become negative ion. Now, different ions of the same group usually carry the same amount of charge. You look here, the group 1A element, sodium ion, potassium ion, rubidium ion, and cesium ion, they contain same charge plus 1. On the other hand, group 7A elements, fluoride ion, chloride ion, bromide ion, and iodine ion contains one negative charge. That means same charge they carry, and the radii of ions increase with increase in atomic number. And the reason behind this, when an atom loses electron from outermost shell, the remaining electron feel greater attraction from proton of nucleus. And lastly, I would like to discuss variation of ionic radii in period. In a period, size of ions cannot be compared with the increase of atomic numbers. That is, size has no similar change. In a period, charge number is different in different ions. For example, in the third period, look here, sodium ion, magnesium ion, and and aluminium ion, and sulfur ion, chloride ion, etc. They uh, maintain no similar trend. Here, if we move across the period of the periodic table, the ionic radius decreases for metals forming cations. Here, sodium, magnesium, and aluminium, they form cations as the metals lose their outer electron orbitals. But for non-metallic elements, the ionic radius increases. Look here sulfur ion, chloride ion, their radius increases because there are more electrons than protons. Therefore, ions may be larger or smaller than neutral atoms. For example, if we compare sodium atom whose radius is 0.157 and sodium ion whose radius is 0.97. If we compare, we see that sodium atom, the radius of sodium atom is greater than the radius of sodium ion. So, for cation, atomic radius is greater than ionic radius. Atomic radius is greater than ionic radius. That means sodium greater than radius of sodium is greater than sodium ion. On the other hand, for anions, atomic radius is smaller than ionic radius. On the other hand, I repeat it again, on the other hand, for anions, atomic radius is greater than atomic radius is greater than on the other hand, for anions, atomic radius is smaller than ionic radius. For example, if we compare fluorine atom and fluoride ion, then fluorine at radius of fluorine atom is less than or is smaller than fluoride ion, and radius of fluorine atom is 0.072 nanometer and fluoride ion is 0.133. So we can see here the atomic radius of fluoride is less than atomic radius of fluoride ion. Uh, I have told you earlier that this chapter is very important and today's topics are also very important for your exam. So, memorize this chapter properly. Memorize this chapter properly. No more today. See you again in the next class. Take care. Bye.